You've heard of designer clothes. How about designer kids? Gene therapy is the remarkable treatment of disease by modifying human DNA, which are the special molecules that carry all genetic information. Gene therapy may sound like a normal medical advance. It is not. The restructuring of our genetic material is a revolution. But how far should we go? If we intervene and adjust human genes, do we impact and alter human evolution? Next, on Closer to Truth, will gene therapy change the human race? Welcome to Closer to Truth. I'm Robert Kuhn. Gene therapy is power, with a capacity to cure or corrupt, heal or harm. We invited 5 world-renowned experts to examine a volatile medical future. Dr. W. French Anderson, director of the Gene Therapy Laboratories at the University of Southern California, is called the father of gene therapy. Dr. Francisco Ayala, a geneticist at the University of California at Irvine, is called the Renaissance man of evolutionary biology. Dr. Alan Tobin is director of UCLA's Brain Research Institute, where he treats neurological diseases. Dr. Gregory Stock is director of UCLA's program on medicine, technology, and society, which focuses on genetic engineering. And Dr. Sherwin Nuland, the author of How We Die, is professor of surgery at Yale University, where he teaches medical ethics. French, you are director of USC's Gene Therapy Labs and been called the father of gene therapy. Tell us, what is the excitement of the field?
Well, what's exciting about gene therapy is that over the next 20, 30 years, gene therapy will probably revolutionize the practice of medicine.
How so?
In that, since the basis of our cells, the basis of our bodies is really in our genes, it's really the genes which are the foundation of which our whole health is based. So that it should be possible, as we learn all the genes and what they do and how they function, to be able to give back normal genes when we have genes that are deficient or weak. So if we have a tendency to develop cancer, for example, to be able to get a gene that protects us from that cancer.
Francisco, you are an evolutionary geneticist. In fact, you've used DNA as almost a molecular clock to track evolution. Are you a little concerned that gene therapy might inadvertently tamper with the process of evolution, which so far has held us pretty well?
Well, I am concerned, of course, but I am mostly concerned that gene therapy or attempts of gene enhancement may impact humans in other ways also. The process of evolution is very slow, and in the scale of human evolution, gene therapy is going to have a very, very small impact. It just is a different scale.
Yeah, but if you change genes in the human population pool artificially, that could have a different impact in the slow evolution.
Well, the problem is that gene therapy also is a very slow process. Take a typical disease, cystic fibrosis, muscular dystrophy. The frequency of these genes in the population is of the order of a few percent. So if you take a gene that exists in the population in 1%, and if you cure everybody who is born with the disease and change the gene, correct the gene, it will take 100 generations, 2,500 years to go from 1% to half of 1%. So it will have very little impact. The reason is simply that all the genes that cause diseases have already been kept at very low frequency by natural selection.
We're going to get back to this a little bit later. Alan, you've been interested in how cell biology and molecular genetics can be used to create new therapies for disorders of the brain. Can you tell us some of these disorders and how it might work?
Sure. So we're interested in how we can use gene therapies to modify cells, to modify somatic cells.
That's
cells
somatic
within
body
the
cells.
Cells in the body. In particular, I've had a long-standing interest in Huntington's disease, which is a genetic disease that causes a loss of coordination, what's called a chorea, or dancing-like movement. So we're looking into ways in which gene therapy can be used to both to understand and to modify the process of neural degeneration in diseases like Huntington's disease, Alzheimer's disease, Parkinson's disease, epilepsy.
Greg, you focus on genetic engineering and you're a futurist. Look out to the future for me. What do you see out there on the horizon for gene therapy?
Well, I believe that gene therapy will, not therapy particularly, but when we start to get to more profound manipulations, enhancements, and things of that sort, that it's going to have very, very dramatic effects on human evolution. And that this slow process that Francisco was talking about is something that is really being supplanted. And that just as our technology has reshaped the world around us through a social evolution very, very rapidly at a pace that's orders of magnitude more rapidly than anything in the past. Now these technologies are becoming so powerful that they're able to be redirected back upon ourselves, and I think they're going to
Are you worried about
reshape
that?
human beings.
You worried?
No, I'm not worried about it. I think that
I'm worried.
Well, it's not surprising, because these things have such dramatic impacts on us. It is going to change life as we know it. And that's very disturbing at a number of levels. But it is not just through genetic engineering. There are other things that are occurring that are going to have dramatic implications too. Artificial intelligence, the way telecommunications has knitted us all together. Life is going to change dramatically.
Shep, what concerns do you have as you look at the human condition as it might be affected by the dramatic changes in gene therapy?
Well, first let me say I'm always skeptical of words like revolutionary and dramatic. It hasn't happened yet. I'm not so sure it's going to happen, and perhaps I can be a little bit of a dissenting voice here. If it happens the way it is predicted, and if it happens in such a way that it will, quote, change the human race, the question obviously is, do we want to change the human race? Have these 3.6 billion years of evolution since the first life appeared on Earth meant anything? And is there a guiding biological purpose? If so, do we really want to play with it?
Fundamental question.
Well, the fundamental question really is, what is humanness? Is it our spiritual sense? Is it our sense of mystery? Is our ability to love, to be altruistic in ways that animals can't? Do you really want to run the risk of changing this? Do we know the consequences of what we're doing? It seems to me that any new technology that can be revolutionary or can change the world should demonstrate first that there is unambiguous benefit to come from it before we begin applying it.
French, let's take a role play. Take a serious situation where I would come to you as a patient, perhaps with a disease that is treatable by gene therapy, and I don't know really anything about it, and my physician has recommended me to you as the person who perhaps can help me in this experimental procedure. What would you be telling me in that first office visit?
Well, the first thing is to emphasize what you just said, and that is that there is no treatments yet that are successful using gene therapy, that it is an experimental procedure, and certainly in future years there certainly will be treatments. Those experimental procedures which are now carried out, and there are now over 300 approved clinical protocols for gene therapy, what the main thing that is done is what's called an informed consent. And the informed consent is to go through a process and a document so you understand what your disease is, or your child's disease, what the procedure is, what the risk of that procedure are, what the possible benefits, and what the likelihood that there will be any benefit at all.
So, what are some of the diseases that I might have?
About 70% of the clinical protocols are for one form or another of cancer at the present, be it